Hi, I'm Doug Phillips. I'm here in southern Utah to talk about the age of the Earth. I'm going to look at some rocks in this area, and we'll do a little demonstration that will allow you to see for yourself, using nothing but your eyes and your own brain and a little math, how old the Earth really is. Creationists say the Earth was created in 6 days and is 6,000 years old, and science says it's billions of years old. These are two very different answers, and they can't both be right. Scientists around the world agree on the 4 billion-year-old age, but a large portion of American adults believe in the creation story, including some very prominent people in U.S. politics. This is the Virgin River Valley of southern Utah. It's desert country, plateaus, mesas, buttes. A lot of formations like this, where you get a very hard rock that kind of makes a flat spot, that makes it hard for the rain to wash it away, and a slope made of softer, broken up rock that falls away. You'll see that on the far side of the valley over there. It's flat top. It's got several layers. You can see the layers in it. If you look at the top part, the cap that's kind of split into two pieces, below that is some red rock. And there's two distinct hard capped layers in that red rock with slopes in between them. And below that is a layer of white rock, or whitish rock, and it's got some layers in it. And then below that another layer of red, and below that another layer of white. It alternates back and forth between red and white, always with these very hard layers, just like this one that I'm looking at right here, in between. If we look across the valley, and it's a pretty big valley, way over on the other side is exactly the same thing. Up on top, it's got the same top hard rock cap that the other side had. It's got two distinct layers of red hard rock, followed by white, followed by another red, followed by another white, which is where I'm standing. So you can imagine that at some point in the past, this rock on top of that mesa connected all the way across this enormous valley to the far side. If you get a little higher, as I've done in this Google Earth view of the Virgin River Valley, you can see that the South Mesa is really part of a large, flat plateau that goes on for miles. It's only in the Virgin River area that this plateau has been worn away. At some point in the past, this was one continuous plateau, and the rocks on the north connected all the way to the south side. But wait a second. It's 6 miles across this valley and 2,000 feet deep. How did the puny little Virgin River cut away all that rock and dirt? Well, there are three main forces at work here, and the Virgin River is only one of them. Rain and gravity are the other two. Let's see how each helps to form this valley. First, the flowing water makes a slot. You can see that happening here. The river cuts down and carries away sand and small rocks and forms a narrow canyon with two walls. At that point, rain and gravity take over. As the softer rock becomes soaked by rain, it breaks down into sand and it forms a slope. With each rain, some of the sand is washed downhill, moving the slope further back away from the river and slightly widening the valley. The harder rock forms a flat layer, less affected by rain. But as the rain washes away the sand beneath the hard rock layer, it produces an overhang. And as the hard rock heats and cools each day, it's only a matter of time before cracks form and gravity causes a chunk of rock to break off and fall to the slope below. These three forces show us how the valley was formed. Does it make sense? If we know how the valley formed, the next step is to figure out how long it took to produce what we see today. But how? I'll give you a hint. Focus on the boulders. I'm standing at one of the spots where we've got a layer of white rock on top of a layer of red rock. So you can see behind me here, we've got the red rock down below. We've got the white rock up a little higher. And all around me are white boulders that have cracked off of the white rock layer. For example, here's a broken area of white rock that looks like it's nearly ready to fall. And on the ground are some other pieces that have fallen off recently. Here's another example. This larger red boulder is very square shaped, and you can see right where it came from. That lower layer of hard red rock is full of vertical cracks, and you can even see some other square-shaped boulders that will be falling out in coming years. I'm near the top of the mesa now. Do you see the dark cap rock on top? The slope I'm standing on is littered with large dark boulders that have all cracked off of the cap rock layer. These dark boulders are scattered everywhere. They've all come from the same place, the top of the mesa. It's like a jigsaw puzzle, where half the pieces are scattered across the floor. If I had some heavy equipment, I could pick these boulders up and piece together the crumbled cap rock, just like an archaeologist reconstructs broken Greek pottery. You can see the cap rock of this mesa now lies in ruins all across the slopes below. The hard rock layers are all retreating further and further away from the Virgin River, and that means the softer slopes themselves are also retreating. Let's focus on the boulders to estimate how long this process takes. Based on what we see around us, the boulders appear to be breaking off when the overhang is between 5 and 10 feet. Why? Well, we don't see any overhangs larger than that, and we also don't see any boulders bigger than that. So how long does it take for nature to produce 5 feet of overhang? Well, to make the overhang, the softer sandy slope beneath has to wash away. This happens a little each time it rains. We're in the Utah desert, and it doesn't rain very often. About 10 or 15 times each year, there's a rain big enough to move some sand and small rocks down the hill. How much? Well, for every 100 feet along the slope, about 8 cubic feet of sand and rocks are moved downhill by the rains that fall each year. Enough sand to fill a bathtub. Does that seem reasonable as you look at this picture? Now consider how much sand we need to wash away to create a 5-foot overhang. For every 100 feet along the slope, we have to remove 5 times 10 times 100, which equals 5,000 cubic feet. If the rains are washing away 8 cubic feet each year, then to wash away 5,000 cubic feet takes 650 years. Think about that. The 5-foot overhang you're looking at now has been in the making since the 14th century, well before Columbus arrived in America. Now that we know how long it takes to remove 5 feet of rock, it's easy to estimate how long it took to create the valley that we see today. From where I'm standing, this valley is about 6 miles across. If it takes 650 years to erode away 5 feet of rock, then to remove 6 miles out of the original plateau took a little over 4 million years. It happened just as we've seen with our own eyes, little by little, each year removing a little more sand, undercutting the hard rocks, and causing boulders to crack and break off. It's far too slow for us to watch. There's no YouTube video that shows it happening, but we can easily calculate what's happening and how long it takes. The Virgin River flows quickly because the land in this area is fairly steep. Carving a river valley like this one in a few million years is considered fast. Slower moving rivers do the same work, but take even longer. Scientists estimate a large canyon like the Grand Canyon took 17 million years to produce. And gently sloped river valleys, such as the Hudson or the Ohio rivers, can take as long as 100 million years. So how old is the Earth? Well, we've seen it takes many millions of years for a river to cut through layers of rock to create a canyon or a valley. But you have to ask, where did those layers of rocks come from in the first place? Most of them are made from the sand and the mud carried downstream by rivers of the past, now long gone. Those layers of rock we see today are the remnants of countless other canyons and valleys of the ancient past. This process of cutting through rocks in one place and depositing sand and mud in another has been going on over and over throughout Earth's history. Each cycle takes many millions of years, and the layers show us this cycle has repeated hundreds and hundreds of times. It turns out the Earth is very ancient. So I hope you've seen that just using your eyes and your brain and a little bit of math, we can figure out about how old the Earth is. It's not 6,000 years old. It's billions of years old. Hope you've enjoyed watching.